So let me first write a couple of the common, uh, categories of time complexity, and I can show you one examples of each of them. So I'm writing this in, increasing order, so that, and I'm only writing the most common ones which are there out there, like which we use. There are multiple different time complexities as well, but I'm not considering them at this moment. So first, let's talk about O of 1. So if I say write any function, okay, I'm getting a word, okay, I'm getting a word string word, and what I'm doing is I'm printing hello plus word. So let's say if I call the function with world, the string world, it will simply print hello world. No matter the input, no matter how big a word you send here, the print statement will always take O of 1 to execute, right? So this is what constant time algorithm means. It does not depend on the input length. The input length can be as big as 1000 words. It will still take O of 1 to execute. All right. Now, before going to log n and root n, let's talk about n first, because from n we can derive log n and root n as well. All right, this is done. For O of n, let's take an example. Let's say I have another function which is count. It's a count function. Basically what it does is it's count the value from 0 to n minus 1. So if my input is 5, I will count like 0. It will print basically 0, 1, 2, 3, and 4. So I will get an n value here from as input, and I will simply run a for loop. Less than n I plus plus. Also I plus plus, by I plus plus I simply mean it can, we can also write it as I plus equals 1. It generally means that I is equal to I plus 1. So after each iteration of this loop, I gets incremented by 1. And here I'm printing the value of I. And that's the function. Now, if I call count with 5, this loop should run for 5 times, right? If I call the same count function with say 1 million, this should run 1 million times. So as the value of n increases, the value of count also increases. So the time complexity becomes O of n, because the program will run exactly n number of times, and it's dependent on the value n. Now, say I add a plus 5 over here. Does that make my, time complexity as n plus 5? It doesn't, because when we are when we are working in an industry where we have a huge amount of customers and data, for example, Facebook has 2 billion customers, right? I don't think 2 billion plus 5 will make any more of a change, and just not 5. This is not just about 5. Even if it's 2 billion plus like 1 billion, and this 1 billion is a constant, we still won't consider it. We will always say it's O of n, not O of n plus 1 billion, not O of n into 1 billion. It doesn't matter. If this is a constant, we won't consider it while analyzing our code, because that is constant always. It does not change with the user input. This part was clear? Any doubts? All right. Let's move ahead. So O of 1 is done, n is done. Sorry, n is done. Now let's talk about log n. So the same loop, but I will change a little bit into it. I is equal to 0. I less than n, I into equals 2. So after each iteration, I becomes, basically if I is 1, if I is 1, in the next iteration, I becomes 2. In the next iteration, it becomes 2 cross 2, 4. In the next iteration, it becomes 4 cross 2 is equal to 8. In the next iteration, it becomes 8 cross 2 equals 16, and so on and so forth. So here, I'm just printing I. Okay. So what should be the time complexity of this? Now, let's dry run this algorithm. And I'm showing you dry run because it's a very important skill to have when you're debugging a problem, because whenever you are stuck on a problem and you are not able to figure out how this entire thing is going to work out, it's always better to, go from start to end and see how your code works. Okay, so let's dry run this. So my I is 0 at first. It comes into the loop. It prints 0. Okay, I got 0. My I's value is 0 and I printed 0. Next time, what happens is I becomes 0 into 2, and this is also 0. So this is one reason why we should always dry run, because when we dry run, what happens is this was 0, right? I put it 0. This should have been 1. If I put 0, anything into 0 is 0. So even in the next iteration, it becomes 0 into 2 is equal to 0. And this will go on till eternity, right? So this gets trapped in a infinite loop. So this is why we should always dry run. We get to catch our errors. So this should not be 1. Sorry, this should not be 0. This should be 1. If it's 1, let's remove this part. Let's see here. So for the first iteration, we print 1. For the second iteration, it becomes my I was 1. For the second iteration, it becomes 2 into 1, which is 2. It printed 2. In the next iteration, my I was 3. It printed 8. Sorry, not 3. Sorry. So sorry. This was 2 cross 1, right? Which is equal to 2. So it printed 2. Next time again, it got incremented by, it actually didn't get incremented, it got multiplied by 2. So now it's 2 cross 2, which is 4. So this is 4. In the next iteration, it becomes 4 cross 8. And now I cannot print 8, because as soon as I becomes 8, I less than n is basically 8 less than 8 is mathematically incorrect. So my loop gets out of it. So I print 1, 2, 4 till there. So for n is equal to 8, for n is equal to 8, okay. Sorry. I forgot to tell you that n was 8. Sorry. So n, we were considering with n is equal to 8. That's why we broke here. So when n is equal to 8, my program ran my loop ran 1, 2, and 3 times, right? So this is how we form logarithm. Like if some of you knows logarithm, this will be very easy for you to catch. But for those who don't, it's okay. Like you guys can learn it as well. So for n is equal to 0, or if n is equal to 0, this should not run any times, right? This should not run. For n is equal to 1, this should run. I is equal to 1, 1 is less than 1. It should run 0 times, right? Because 1 is less than 1 is also not mathematically correct. For n is equal to 2, it should run 1 times. 1 is basically 2 to the power 0. For n is equal to 4, it should run. For n equals 4, it should run 1 times. For n equals 8, it should run 3 times. Sorry, for n equals to 4, it should run 2 times. For 1 and then for 2. For n is equal to 8, it should run 2 to the power 3 times. for n is equal to 16, it should run 2 to the power 4, basically 4 times, like it should print 4 times. For n is equal to 32, it should run 5 times. Basically, it's going in the values of 2. So for n is equal to n, it should run 2 to the power k times, where k is an assumption right now. So 2 to the power k is equal to n, or k, basically then what we do is, here is, okay, let me remove this for now. Done. This is going on. So 2 to the power k is equal to n. Okay, this is what we got by deriving that algorithm. I know this derivation might seem a little confusing at first, but this is like, you will see this in binary search, you will see this in merge sort, you will see this in most of the tree problems. So this idea will get clear as time passes. So don't worry about it. So one of the famous, one of the most common logarithm algorithm is basically that you simply, if you do log 2 to the power k is equal to log n, okay, and the base is common. I did 2 for a purpose, because my the base, the number that I'm dealing with here is 2. So I kept the base same, because if the base and the number are same, they get cancelled out. The k comes over here and it becomes log 2 is equal to log n. This is also 2 as well. Now 2 and 2 gets cancelled out. This value is basically equal to 1. So k into 1 equals log n, or k is equal to log n. And now what was k? It was basically like, for, you remember 2 to the power, for n is equal to 8, it was running 3 times. That's why we wrote it like 2 to the power 3, right? For 2 to the power 4, for like basically for n value 16, the loop was running 4 times. For the value n, we assumed that it should run k times, right? And here k is log n. So basically your algorithm will run log n times. Now let's talk about root over n. So for root n, the loop remains the same. It's basically, there are 2 ways to write it. I into I is less than n, I plus plus, or we can write the same thing in I is less than root n. Any way that is like basically feasible to us. It depends on the problem. It's basically programmer's preference. Most people go with this. Some might also go with this as well. So basically this will run for root n times, as like it will always run when till I is less than root n. So if n value is 16, I will run for basically 4 times, right? For 0, 1, 2, 3. And then as soon as 4 becomes 4 square is equal to 16, the loop gets broken and we are good to go. All right. So root n is also confirmed. For n square is not that big of an issue, like really, because n square, basically what we do is we generally get n square when it's a 2D matrix. Okay, so if I say let's take a matrix first. Let's say I have a 2D list in this form: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, if I have this, then basically if I represent this in the matrix form, there are basically 3 rows, right? This part is the rows section, this part is the column section. So my I will take care of the rows and my J's will take care of the columns. So let's go ahead. And now I can simply print array. So basically this was array I, j. So in this case, what happens is this runs 2 times, right? So it's order of n into n, or order of n square. So n square generally comes when we have a nested loop. Okay, like we are having right now here, a loop inside a loop. That is generally 10 to as order of n square.